Hey, what's up, students? I wanted to help you out a little bit with some of the 4-3 questions. The number one thing that's going to help you out, I pulled a couple questions right off the 4-3 test. One thing that's going to help you out, friends, is when you're doing these matching problems, when they give you a list of ordered pairs, is to put the ordered pairs into a vertical table. Reading things left to right is cool with words. It's kind of hard with numbers, though. So go ahead and put all the x coordinates in one column, the y coordinates in the next, and then do the same thing every time you see this. And now it's kind of easy to spot the pattern. So right off the bat, one thing that I like to look for is I like to look for vertical patterns. If it's a vertical pattern, then it's going to be one of these two problems. Okay, when you have a number as your base and then as the x as the exponent, that means a vertical pattern is going on. Basically what this means is you start and you multiply by 2 over and over and over and over again. This repetitive multiplication of 2. This is a repetitive multiplication of 3. The more time you spend looking at these, the more you'll see these patterns. So I would recommend spending some time in the homework and some time in the notes. So right away, I'm pretty sure looking at this table, I don't see a vertical pattern, but I do with this one. Okay. So with this set, it looks like, oh, you're just taking it times 2, times 2, times 2, times 2. I'm probably not going to be multiplying 3 over and over and over again, so go away. I think this would be the right answer. I can double check if I want really quick. Let's see, if I took 2 to the 0 power, it's kind of weird. When you put in 0 as an exponent, everything turns into 1. It's like nothing happens. Okay, so 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second is 4. 2 to the third is 8. Yeah, it's just times 2 over and over again. Times 2, times 2, times 2, times 2. This is the function that does that. Boom, got one figured out. So let's look at this one here really quick. I don't see a vertical change. It's not times plus 1. It's kind of hard. When you start at 0, by the way, 0 and 0, it's going to be one of these guys. It's going to be x to the something. Okay. When you plug in a 0 and you get a 1, that means x was your exponent. Well, if you plug in a 0 and you get a 0, you're powering 0, which nothing really happens. You take 0 times itself and you get 0. So that's kind of a big dead giveaway. If you see a double 0, it's probably going to be one of these dudes. Now, if there's extra numbers like plus 10, minus 10, you might get that. But for right now, when you plug in a 0 and you get a 0, it's one of these basic quadratics. All right, so let's go ahead and see what's going on here. We have no vertical pattern. Let's look for a horizontal pattern. How do I go from 0 to 0? Well, lots of things can happen. It's going to be either x to the 3 or x to the 2. 1 times itself once or twice is still 1. Ooh, 2 times itself is a 4. 3 times itself is a 9. 4 times itself is a 16. So I'm guessing this would be the right answer right here. Okay. I'm not taking it times itself 3 times. If I were to take itself times itself 3 times, I would still have a 1. Let's see. I don't know why that's so small there. That's kind of weird. I would like it to be normal size, please. There we go. If I took 1, so I'm kind of making another table here using these 1 values. Go and copy it really quick. Watch this. Copy, paste. Let's move you over. Okay. Let's move you up. Let's copy and paste one more time. Copy, paste. There we go. So it's still going to be 0. Oh, why are you tiny? Come on, Google Sheet. You're goofing off here. I don't like it. There we go. And then get centered. Good job. Okay. So if I took 2 to the third power, that's 2 times 2 times 2, that's 8. If I took 3 to the third power, that's 3 times 3 times 3, that's 27. Now if I took 4 to the fourth power, I'm pretty sure that's 64. Okay. So yeah, definitely not x squared. 4 times itself 2 more times, or 3 times totality would be 64. So just kind of breaking it down into a table. Okay. Again, you're only going to see so many numbers and so many lists of numbers. So if I were to make repetitive multiplication with a 3, okay, oops, I don't like you there, go away. Here we go. So watch this. I want to make this a 3 really quick. Okay. So I would start at 1, because 3 to the 0 power is 1, and then it would be a 3, then it would be a 9, then it would be a 27, and it would be an 81. So there's kind of some help right there on how to spot the different quadratics and different non-linears, if you will. Non-linears are kind of weird, students. So it's going to be either repetitive multiplication using the same number over and over, or it's going to be some type of squaring with some type of goofery on top of it. So just do the best you can. Again, the number one thing to take away from this is to organize your stuff into a table. Guess and check using the coordinate points, using different coordinate points. Obviously, these two are the same, so I wouldn't use those to guess and check, but 4 and 64, 4 and 81, yeah, I would totally use those to guess and check. 3 and 8, 3 and 9, yeah, I would use those. Those are different. 4 and 16, oop, those are the same. So use different corner points to guess and check, and that's usually the best way to handle these. We'll see you in class. Goodbye.